let's go right into it and see what you really have to do in order to work with this question. Okay, cool. So we are told here that we need to simplify the following expression to one trigonometric ratio of theta. Very important for you to keep that in mind. Now, this is actually a reduction formulae from trigonometry. Very powerful concept indeed. One of my favorites. I love this. And I want you to understand the following. You cannot be able to work with Euclidean geometry. I mean, not Euclidean, but trigonometry. You can't work with trigonometry without involving the cast diagram. So the first thing that comes to my mind when I'm looking at this, I need to put down the cast diagram and see if you guys remember how this is going to assist us to simplify this. So we know for a fact that this is 0 degrees. We know that this is actually 90 degrees. We know that this is 180 degrees. We know that this is 270 degrees. And we also know that this is 360 degrees. Right. And then we know that any angle in the first quadrant can be represented as 90 degrees minus something. Or in the second quadrant, there are more than 90. So you can write that as 90 degrees plus something. 180 minus is going to be here. And then this side, we're going to have 180 degrees plus theta. And then it's going to be 270 degrees minus theta. This side, you are looking at 270 degrees plus theta. You're also looking at 360 less than theta by some amount. Very important for us to keep this in mind. And this, like we said, is the cast diagram, because in the first quadrant, all trig ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, we know that cos is the one that is positive. Right. So it's important for you to understand where this is going to actually help you in trying to find the solutions to the questions that you're working on. Remember, guys, what we're doing on this show is not really about the actual question we're looking at, because we understand you may never find the same question again, but what we want you to live with after watching the solution here is the concept, the underlying concept. I want you to understand, how do you really work with these kinds of questions, the general idea around what you're looking at. So that's what we're actually trying to work on here. Okay, cool. So now I'm looking at these now. My job is pretty simple, to figure out in which quadrant does a particular angle that they're talking to me about lie, right? I want you to be able to see that. Now, when you look at 180 minus theta, the first part that we see there, we can clearly see that this is from the second quad. So we won't have a problem with that one. This is from the second quad. Now, there are angles that are troublesome, like this one. This 540 here might be a problem because you don't see 540 unless if maybe at your school they have helped you to figure out how to work with that. The other problem is this one, where suddenly it's not 90 minus theta, but it's now theta minus 90. So those ones, we need to understand, right? If my angles suddenly become more than what we see on the first revolution, or on the first revolution that you're looking at here, if they become more than 360, 700 and something, 540s, 630s, those ones, how do you really work with them? That's the first problem. The second problem is, what if my special angle, right, or my terminal ray angle is not equal to the ones that I'm looking at, is not even positive, but it's less than 0 if it's negative? How do you actually work my way around that? Very important, because you see 540 is too much, and then minus 90 is negative, it's less than 0. So how do you deal with those two conditions? Okay, cool. So here's the idea here, guys. This is what you will always do, right? If your angle, right, if your angle is greater than 360, if it's too big, what are you going to do? You're going to always subtract, right, 360 degrees from it. It always works all the time. But if your angle is less than 0, which means if it is negative, you're going to always do the opposite, which is to what? You're going to add 360 degrees. This should be enough to carry you through any question that you might need to worry about in this context. So I'm going to start by, first of all, working with those. I'm going to say, okay, that is equal to the sine of 180 degrees minus theta multiplied by the sine of, now that's 540, beautiful people. I don't like 540, it is too much. So I'm going to remove 360 from 540. When you do 540 minus 360, because you're trying to downsize it, it goes straight to 180 degrees. And then this is going to give you 180 degrees minus theta. The second problem we have is that one, of course, of theta minus 90. Once more, I don't like that. I think I want that minus 90 to be something, so I'm going to say, on that minus 90, can you please add 360 degrees? We're trying to upgrade this one. When you upgrade, it goes straight to 270 degrees. It's a very hefty trick that you can use. It works all the time. You will never struggle when you're dealing with this. So this is as good as cos of 270 degrees plus theta, because theta has always been positive, it will remain positive. All this needs to be divided by the tangent, right, of negative theta multiplied by the sine square of 360 degrees minus theta. Right. Now that I'm here, I'm now ready to start reducing all these guys. Remember, we are reducing them. This is the reduction formula. Very powerful indeed. Sine of 180 minus theta, you always check which quadrant does this thing belong in, and after that, you then decide if your answer is going to be positive or negative. 180 minus theta is an angle in the second quadrant. We can clearly see it there. And in that quadrant, sine is positive. So whatever reduction I'm going to get from sine 180 minus theta is going to be a positive reduction. And it's going to reduce to exactly sine of theta, right? Multiplied by. Once more, we have another sine 180 minus theta, which is also in the second quadrant. And sine is positive there. We're going to get another positive sine of theta times. Now, these ones are the hot ones. I always tell people to keep that in mind. They're very, very important. Any reduction that involves 90 or 270, your trig ratio will change to its core ratio. Please keep that in mind. Cos will change to sine, sine will change to cos. So cos 270 plus lies in the fourth quad where cos is positive. So I'm going to get a positive result, which happens to be the sine of theta and not the cos of theta. Please pay attention to that. It's very important for you to look at it. Now, tan of negative theta. Right, guys. Negative angles, if you count, we're counting positive when you're going anti-clockwise. So 20 degrees will lie in the first quadrant. But negative 20 will lie in the fourth quadrant, because instead of going anti-clockwise, you're now going clockwise. That is regarded as the negative way of calculating it. That's the negative direction of figuring out our angle. So tan of negative theta is not in the first quad, it is going to be in the fourth quadrant, right? So tan of negative theta is in the fourth quad. In the fourth quad, tan is negative, so this is going to be negative tan of theta multiplied by sine squared 360 minus. Even though this is in the fourth quadrant, where sine is supposed to be negative, it is going to boil down to a positive quantity, because anything squared will always be positive. Please keep that in mind. Anything squared will always be positive. So it doesn't become negative, it's going to be positive. Now from here you can see you're going to divide now. Sine times sine is sine squared, they'll cancel that sine squared out. What does this leave us with? It leaves us with sine theta divided by negative sine theta all over cos theta, which comes from our tangent, which we can then simplify further and say this is as good as sine theta multiplied by times. You put cos on top, and then you put negative sine theta on the denominator. That negative can be anywhere, by the way, beautiful people. It doesn't really have to keep following sine. So that will cancel with that. And then they said this needs to be a single trig ratio. You can see cos over negative 1 is just going to give us a value of negative cosine of theta, and then gives you exactly the simplification of this beautiful question.